So this was originally, this question 4 was actually question 7 in the 2016 paper 1, leaving aside paper. So air is pumped into a spherical exercise ball at the rate of 20 centimeters per second. Find the rate at which the radius is increasing. When the radius of the ball is 20 centimeters, give your answer in terms of pi. So they want you to find the rate at which the radius is increasing. So the radius is increasing. So rate it's increasing is just a rate of change, and we're dealing with the radius. So what they want you to find is d or dt. Keep that in mind. They want you to find d or dt. The rate at which they're your two variables, the radius and time. Okay, so when they talk about air being pumped into a spherical exercise ball, what we're dealing with here is volume, the volume of the ball. So that's the first formula you got to have in your head. Volume is 4/3 pi r cubed, and when you differentiate that, you get dv dr. Okay, it's the or dt we want, but at least we differentiate this, we get something. So the 3 comes down, 3/4 of 12 divided by 3 gives you 4 pi r squared. So that's what dv dr is. Now, they also talk about air is pumped into a spherical exercise ball at the rate, so this is some sort of rate of change, at the rate of 250 centimeters per second. So you have to think about what that is. So you were trying to get d or dt. You've got dv dr. They've also given you in the question here dv dt. Let's look at what that is. It's this 250. If 250 centimeters cubed is going into the ball, then its volume is increasing by 250 centimeters per second. So it's dv dt, it's the volume of the ball is increasing. So by differentiating volume, you get dv dr. By working out that this here was dv dt, you have that there. And d or dt, well, d or dt is got by multiplying dv dr, it's got by multiplying dv dt. That will give you your dt at the bottom, and you have to flip this around, multiply it by d or dv. And that way your dv's cancel and you're left with d or dt. So that's how you're going to get it. So your dv dt is 250, and your d or dv is going to be this turned upside down. So it's 1 over 4 pi r squared. And you have to find d or dt when the radius of the ball is 20 centimeters. So you now need to substitute 20 in there and just write down what you get. So it's 250 over 1 multiplied by 1 over 20 by 20 squared is 400. 400 by 4 is 1600 pi. So that's giving you 250 over 1600 pi. Stick that in your calculator. Just work out that it's going to be 5 over 32 pi. Second part of the question, find the rate at which the surface area of the ball is increasing. So what are they asking you to find? They're asking you to find the rate at which the surface area, so area, they're asking you to find dA dt, the rate at which the area is changing. So the rate at which area changes with respect to time. When the radius of the ball is 20 centimeters. So they're asking you to find dA dt. So area of a cylindrical ball, curved surface area, is equal to, surprisingly, area is equal to this. But you can look that up it's linked to that. It's linked. Area is 4 pi r squared. Curved surface area of a sphere is 4 pi r squared. So if you differentiate that, you get with dA dr, and that would give you 8 pi. So you've got dA dr, and you're trying to get to dA dt. So if you had dA dr, and you were to multiply that by dr dt, you would end up with dA dt, which is what you're trying to get. Okay? So you have your dA dr is 8 pi. Dr dt, you've already worked out to be this 5 over 32. Sorry. Yeah, your dr dt you've worked out to be 5 over 32. That's right, yeah. So you're just multiplying it straight up by 5 over 32. It's 5 over 32 pi. So your pi's are cancelling for you there. And you're getting 5 fours are 20 over what have I done on here? It's 8 pi r. I knew I was missing the r. So you're getting 5/8 of 40 r over 32. And again, you have to substitute in 20 5/8 or 40. You have to substitute 20 in, yeah, sorry. 40 by 20 all over 32. So, if you do that on the calculator, 40 by 20, not 40 by 20 divided by 32, it's giving us 25. So that's centimeters, because it's area, it's centimeters squared per second. Yeah, so again, just work your way through them slowly. This one over here, well, first of all, this bit here is integration, so we haven't done that yet, but looking over at this bit here, the inflated ball is kicked into the air from a point O on the ground, and if you look at your function already, you see that it's a negative quadratic, so it's going to go up like this, right? This is O and this is some other point in time. Fx approximately describes the path followed by the ball in the air, where that there is your function, and both x and f of x are measured in meters. So find the values of x when the ball is on the ground. Okay, so yeah, so the first thing you got to do here is factorize your function, because you're essentially trying to find the roots of your equation here. So if you factorize minus x squared plus 10x, if you factorize the x out of it, you're left with minus x plus 10. That's going to be equal to 0. So you've got 10 is equal to x and 0 is equal to x. They're your two factors. So the ball essentially is at the ground at point 0, and it's also at the ground at 10 seconds here. So it's 0 seconds. So taking O as the origin, yeah. So it's 0 seconds and 10 seconds are your two times when the ball is at the ground. That's it.